I forgot to edit it. So it's just you're live.
Uh,
Were we doing a live?
Together.
No, I can't do it yet.
Oh, all right. I'm so confused now. I'm like above, beyond confused, but we'll work through it.
Yeah, you were talking about doing a live earlier today. I thought you meant with me doing it for you, but this one's not able to do it till tomorrow, and we knew that.
Oh no, I thought it was, but no, it's all right. Misunderstanding. Too much information. TMI moment.
We got TMIs. You got to clip that light off.
This one.
Yeah. All right.
Now we're gonna turn this bad boy on, and it's gonna light this light up really, really bright, but it's gonna be flashy, and it might be because of the way these coils ended up being wrapped, but they feel really tight. They're really tight. They're not that disuniform. I'm thinking the problem's in the switch, the paper clip. The plasma. Right now we got some minor arcage. We got all these coils hooked up in series with diodes, as you can see right here. There it goes at 20 volts, man. That's awesome.
Whoa.
Now we got good pressure on the switch. Good pressure on the switch. It's trying to arc every time it hits, which is good. We're drawing a little bit of amperage because of the pressure though. 170 milliamps. We don't need to go any higher than 36. And we're going to see if that tapers off. It's going down right now. Well, you don't have to. It's 130 milliamps now. 140, 130, 140, 130. 112. Yes. 120. My bad. Alright, now we're down to 80, 70. Oh, yeah. Look at how much stabler that is when it dips below 100 milliamps.
Nice.
50 milliamps. 40. Fluxing between 60 and 40 right now. And that's good. This is an 8 magnet rotor. We'll let that simmer down. It's got tremendous flywheel capability. This will spin like this for 25 minutes. Like 10 minutes. But I want to show you a 4 magnet variation of the same thing.
What's up, Kara?
Hey, hey. How's it going? Voila, 4 magnets. 100% ceramics, maglev. We'll give it a little spin.
Welcome in, T-Lon. Thank you guys for dropping by.
Hello, hello. This is a 4-magnet variation of the same thing, basically. It's a lot lighter, sits a little bit higher on the maglev.
Maglev. Let me know if you need a closer look at that. No, we don't measure the torque.
No, I don't even know how to do that. I
Welcome
guess you
in.
wrap a string around it or something and try and pull it the other way. I don't know.
Welcome in, Bob. It's yeah, this is all not yeah, you guys, it's over there.
What are we looking at? Power supply?
That's a power supply.
Yeah, it's a 75 volt buck converter. DC energy supply. It does volts and amps. It does 600 watts altogether. We're doing 110 milliamps right now at 23 volts in.
That's right. So it's a pulse motor that keeps on giving
There goes the light.
as long as it's hooked up to the power supply
Yeah.
or some caps or some battery.
Look at that baby spin.
That's pretty intense.
That's awesome. This one's a little lopsided. It's like it's a little wobble, but you can't see it when it's spinning really fast. It's still there though.
You're gonna build a hoverboard.
This is the only transistor I got left right now. This little thing right here. It's pretty good though. You can see it works just fine.
Mm-hmm.
Look at how bright that is, man. That is luminescent.
Yeah, it takes up some light, some part of the screen here for show. This is our time machine. Yes, the time machine.
But the flux capacitor operates on 120. 120 degrees, not 90. So it's a different kind of time machine.
Thank you for the corgi, T-Lon. Appreciate you.
I'm wondering why it's flashing so much though. It's never flashed that much before. I got an idea to test it though. We're going to bypass the switch. Okay, so we unclip the black one, which is hooked to this part of the switch. And then we unhook the green one, which is hooked to the coil right here. And we hook that where the black one was.
Sorry, that was horrible camera work, guys. That's my fault.
Like that. Now I've removed the switch. Let's see if we can get any better light now. Maybe I'm mistaken.
MacGyver. Hey everybody, thanks for dropping in. Welcome to the channel. This is Papa Bale.
Hey, what's up?
We're working with some pulse motor this evening.
Oh, I see where the problem is. I clipped it on top. I'm supposed to clip it on the bottom.
Thank you for the likes, like and subscribe.
There we go. I clipped it on the rubber.
Oh no, I've seen McGruber too. Yeah, it's the same crew uh, that made MacGyver. Or I don't know. I have no idea. I gotta look that up. I think I remember hearing that.
It's a little bit more stable.
Yeah, it's a little dim.
A little dim.
Oh, there it goes. But the strobe effect is less.
Less. So it is the switch. But the switch draws out the plasma. You get arcing when you use a switch. It's a breakout, really.
Let's see. See, like on the phone, I don't have a translate the message. So, Marcos, can you translate that to English? Make it, yeah, man. You can power a Christmas tree with this thing.
Yeah. That's what we're going to do. We're going to power the lights on the Christmas tree. But see how much more stable it looks? I mean, it's still flashing, but it's a lot easier on the eyes. Yeah?
Mm. Oh yeah.
Now what's going to be even better on the eyes is when I put the 8 magnet rotor back on here with the switch bypass like it is.
Power a weed grow. I like that one. Because LEDs have lower wattage demands these days.
Lower wattage, huh? Not these ones.
I think there's some. We gotta look, but the ones we had were 400 watt, bro, and that was a long time ago. Or 12? Was it 12?
I don't remember.
I don't even remember. It was that long ago.
Alright. So we're going to hook the 8 back up, and we're going to see if we can't stabilize it even more.
What's up, South Valley? WTF happened in the world of tech this week? That is on there, and that's a little lower on the maglev because there's more
More weight, yeah.
more manganese. Yeah.
Give it some more time.
What's the smoothest sounding rotor you've ever had? Is it
No.
one of the recent ones or an older one?
No, it's an older one for sure. I think it might be this one. No, it's got to be one of the gray ones. One of these.
Okay. Early on 3D prints. Garvin, what's going on, man?
What's up? Well, that's pretty stable.
Yeah, that's a stable light flow. And this is the 8 magnet rotor, so yeah, it's hitting the coil more often. You can barely tell the strobe now. Welcome to the channel, everybody. Like and
it's
subscribe.
Not going so much faster.
Thank you for dropping in.
It's not the speed that's doing it. Okay, that was an argument that I heard made earlier that it was the speed that was correcting all the mistakes in my coils. No, okay, it's definitely a lot more than that.
Yeah, this is straight up copper, magnets, power, and some circuitry
Now
with
the
copper
coils aren't
wire.
perfect, but I've never needed perfect coils to make perfect light.
That's right.
Never.
Stack it. What do you mean stack it? Do you know?
Yeah, I know what you mean, and I can't.
Okay.
I cannot stack those on top of each other. The magnets are gonna fly out. I've
Oh
already
yeah,
tried.
that's right. That's right.
I've already tried to do it. I want to be able to do it, but it's not going to work because of the way they're built. All the pressure is pushing up, and there's nothing covering it, so they're going to pop out. And I can't put the only two. I only have 3 rotors that can fit on the shaft right now.
Oh man, so that you're limited.
Yeah, I'm limited by the size of the shaft.
Straight
The
up.
bigger shaft has only got 3 holes that will fit. Everything else you're going to have a problem.
Yes.
The other holes are a 1/4 inch.
Oh my goodness.
So, I mean, yeah, like, look, man, that would be great if I could put this one on here. It might even work,
Yeah.
but actually, no, it wouldn't work. This one might work, though. If it was the right size hole, granted. Right, I would have done it a long time ago if it was the right size hole. This one's got iron infused PLA on the bottom, so it would hold the magnets in place while I put it on here, and then it would float. It definitely would float. I've made ones that float before. And I've done that. I've done it. So I mean I know what we're going for. It's just these ones aren't made to do that.
Awesome.
Yeah.
Awesome song. I like that though. Maybe that would be a good. We build like a Christmas tree out of these ones. But we got, we need material for that for sure.
I need to make my cubbyhole one. Make a cubbyhole one where you put them in and then you push them in, and then the magnetism holds them in place. So it's kind of neat. And you could hold it. You could do it upside down, right side up. You could definitely float it on here. It wouldn't be a problem.
What's up, Mental? Welcome in. 10 likes. Thank you for that, Bill.
Oh, thank you.
Building America. We are builders in America, and we are having fun.
Yeah, right.
We're not educated in this. We're kind of going at it.
From a different angle.
hmm So y'all can be all
I'm not an engineer.
physicists.
I'm definitely not a physicist.
What?
I mean, people be quoting Shakespeare to me, and I don't know. I don't read Shakespeare. So it's like you're quoting physics to me. I don't know. I don't read physics.
If it was a cylinder instead of a wheel? Question mark. And then another
Yeah,
one.
maybe.
Just a flywheel? Question mark.
What does that mean?
There's a pulse motor. Is there a fly back or a fly?
No. Well, what it is, I'll explain the connection for the light. I've got one end connected to the end and one end connected to the beginning. And all these coils are connected in series. That should be all I need to say.
Boom. Pulse motor mayhem.
Boing. So all these coils are connected in series. You got me siphoning off the front and the back. They're connected by diode, okay? Each coil has got a diode in between them. A big one, like a rectifier that does 3 amps, 1,000 volts.
And then notice the power supply back here.
Well, bam!
And it's plugged into the wall.
And it's got, because we're not incorporating the switch right now, we're just using the trigger coil. We got 330 milliamps going through it right now.
Right. So like if this turns off, so does that.
Yep, if the power supply goes off, so does the light. And this is a flywheel. It's built, it's got 8 magnets on it. It's got 100% infused PLA on the toroid. So it's really heavy on the outside and very light in the center. It's got hybrid bearings, steel and ceramic. I'm not quite sure what ceramic though.
It's a nice print.
It's a very stable print, yes. Way better than the other 4 magnet one. Way better. That one's kind of wobbly down there.
Ladies and gentlemen, what appears to be a spaceship. Sorry. I had to do it. All right. Thanks, Jay. Appreciate that.
That was awesome. Ladies and gentlemen, what appears to be a spaceship.
It's a little wobbly. Yes, we did make there is a flywheel here, yes.
What it is a rotor that's designed to have flywheel capability. So we have 8 magnets, 8 neodymium cubes adding weight to the edge. And then we've got a 100% 100% PLA infill in the toroid that the magnets are in. So that adds even more weight to the edge. And there's nothing in the middle. A proper flywheel is going to have as much weight as possible. It's going to have the middle's going to be filled in.
And then what was the experiment tonight? Why did you do this setup tonight?
Oh, I don't know. I was working on. I did this setup because I'm good at it. There's really nothing that I can do wrong here.
Certified. We are bros. Yes.
All right. But what I was working on earlier today was this magnificent monstrosity. You got 2 drive coils and you got 4 pickup coils. What I think I'm going to do is make 2 more drive coils and I'm going to hook up a reed switch to each drive coil. And because the drive coils are bifilar coils, they're 20 gauge and 28 gauge, 200 turns, the ones in the front. Yeah. So, and then when we turn it around, the one in the front.
Yep, the doubles.
And then the one behind them is the pickup coil. So these got 2 wires in them. There's one in the front. You got bifilar coils, 20 gauge and 28. And then these are 30 gauge. And these ones on the side here are 30 gauge. And they're all connected in series. The 30 gauge coils.
I noticed my bro was MacGyver probably a couple of years ago. But, you sensed it early on.
This is really where the masterpiece comes into play.
So I don't remember when it came in, but he said, so it's a dipolar motor. I don't know what it's in context to. That's my fault, Jay.
I don't know.
Okay. And what is the purpose?
Yeah, I don't know, bro. Um, but the cows coming home.
The cow's coming
That's
home
the
to.
purpose. Why
That's
did I buy some copper that you were gonna buy yourself?
that's
What did I do? Am I wasting? Am I being wasteful? I don't agree with you. Sorry.
a flux generator.
I can't put this on. I can't put this on here because it'll break the switch. But it's really cool. I got it to spin with one coil. So if I hook up 4 reed switches on 4 coils, every time it hits a permanent magnet on the stator, boom.
Thanks for coming in, Jay. Like and subscribe.
I really appreciate everybody stopping in. But for like the purpose questions, I got nothing for you. I haven't even thought about it, really. I just was interested in building motors. Maybe that's the purpose, to satisfy my interest. Doesn't it, are you
Hmm.
are you pointing that at me?
No. Yeah, I got your head in there.
Okay. That's good. No, that's good.
Appreciate that, Jay.
I love how it picks up, man. It's great. So how we feeling? How you feeling, bro?
I feel pretty good. Let's see what's going on. I'm just kind of right there. That's interesting.
Maybe that's the new you. All right.
Oh God. That sounds smooth.
That's loud.
Appreciate you, Dexter. Welcome in. Thank you for
That
the
sounds
sub.
smooth.
And then thank you for the 500 rubies.
Thank you.
And we got a corgi with that back in the early bit from T-Lon.
Awesome. Cool. So I guess the purpose is the interest.
Purpose is the interest.
We'll go with that.
Yes, I like it.
Am I trying to? Well, I think that electric vehicles need a little bit more options than just pressing the pedal.
Mm.
I think that you should have like so you can like exercise. I don't know, man. Maybe it's better the way it is. But I have a way of like making a switch transmission, a switch clutch for each one of these coils. So when you throw the switch, it's a different combination of coils.
Straight up. Quantum Fart. Nice. That's an interesting name. I like it. Quantum, remember that. And then we build the time machine, and that's M.A.H. Sheen.
Yeah, that's how you spell it.
Time machine.
That was 200 years ago. That's how people spelled yesterday. Mishenne.
Machine. That's the same stuff. Thank you. My eyes are bad. Thank you, Jake. Iltiz. Iltiz? No.
Look how bright that is.
There's got to be a hamster on that thing just losing its mind.
A hamster that's losing his mind. Now he's like, all right. Free energy. The hamster wheel. Get it?
Jesus. Appreciate you dropping in. Thank you for the comment.
Awesome. Stable electricity. Stable enough. You know, all the lights flicker. Even the ones in the ceiling, they flicker.
Yeah, there you go. We are working with pulse motor electromagnetism experiment. What's up, Kid Ball?
Hey man, what's up? That's my member right there.
Yes. Yeah, you got the cool coloring. I'm Bro. I don't know if we've met yet. And he's like, you rock, Holmes.
Oh man. Alright, this is the simple build. I think the electromagnetic rotor is going to be the way to go though. I just have a feeling that if I can develop a switching mechanism that'll work for all four coils without... See, I think it's the stator magnets. I'm using these big rectangle ones. I think I need to use smaller, more compact ones. Because those reach all the way.
Those are hardcore, yeah.
Yeah, man. The field reaches all the way across when it's sitting over here.
Mm-hmm.
So it hits the reed switch at like 8 times as it spins around. And then when you have 2 of them, you blow reed switches like left and right because it's just, it doesn't know. You gotta back it out, or you gotta like get a smaller one, like one of these ones I have on the rail here. But I had it going, not very fast, but I had it going on 2 outer magnets, so 2 permanent magnets and 1 coil. I had it going pretty good.
The brain flickers too, from Kid Ball. The brain just flickers at our observational frame rate though. So it isn't observable. Big reason we have challenges.
I can observe it. You wanna know how I do that?
Oh yeah, it's like making his eyes bounce. It's weird. The big reason we have challenges observing
See, I can make this
helicopter
rotor.
movements is due to the frame rate of cameras. Yep, go ahead.
I can make this rotor look like it's spinning really, really slowly. To me, anyway. But I shake my eyes or I rotate my eyes at a rate that is abnormal. And it slows everything down. So, yay for me. I love this rotor though. Solid.
It's a nice rotor. Hey everybody, welcome to the channel. Thank you for dropping in. This is Papa Bale. Like and subscribe. Let us know if you have any questions.
I love how stable that is, because when we use the switch, let's hook the switch back up. So how we do that is we take the green clip and we hook that up to the end of the switch.
This is a pulse motor, and we got a paperclip switch, 8-magnet rotor, 3D printed, power supply, and then there's coils here too, and a transistor.
And then we hook the black one where the green one was just at. And that puts the switch back in play. Now the switch is active.
And it'll blast some plasma and some sound into the pulse motor circuit and the pulse motor. You can see the arc.
There was some crud built up on the switch from all the heat, or from, I don't even know what it is really, because it's not that hot. There's no sparking going on, it's arcing. The difference between a spark and an arc is sparks are orange and they look like fire. Arc is cold. What?
Whatever pulse motor is used for an application, I pointed at the light.
Oh yes sir.
That's one application.
Yeah, I can run another pulse motor with it.
Charge a battery.
Can charge a battery, can charge a cap bank, so I can charge with it. I can illuminate with it. Just because I can't put it in a car right now doesn't mean it is worthless. So it's fun. It keeps me on the straight and narrow, so that is worth all in itself. If anything else comes of this, that's a bonus.
Are we measuring output anywhere?
No. Should I do that? I'll do that.
We got a what's the output question, yeah.
Alright, here, I'm going to hook the output exactly where the light's hooked up.
Okay. In theory, could it replace an alternator?
An alternator has got a way more machined, clean design, and there would be no point to doing that. I've seen, alternators be recreated and everything like that, and they work better just the way they are. They really do.
Ooh, have it charge your cell phone.
Maybe. Just to hook the output up to something that might be able to transmit wirelessly would be awesome.
Yeah, I got a
All
wireless.
this does is generate.
I got a wireless pad.
So do I.
We can hook up to it.
Oh yeah. I love charging wirelessly. I got way too much stuff already. I just cleaned up.
Oh man, that's sad, man. But yeah, my daughter lives in Albuquerque, so I can call myself a dual citizen there, but I'm in Michigan right now. And no, we do not participate in any of that.
Any what? No.
He says his name is Walter White, and that's a, what would you call that? That's a pun, and Mr. Ben's trying to
So
say that
what
this
happens when you put 50 volts into a pulse motor?
it spins.
Anybody else? You get blue plasma on your switch.
Straight up. blue, blue plasma.
All right, so
The original spin determines the direction of rotation. So we manually spin it right now.
I always spin it clockwise.
Now we have used,
I don't always spin it clockwise, but I spin it clockwise most of the time.
and then have you started it without spinning before?
Yeah, with the switch. Only with a switch. Only when the switch is in a closed position and you flip on the power, will it start it on its own?
And then is it random directionally?
No. No, it is not randomly direction. Depending on where you have the switch,
So position of the switch will.
change which direction it's going to go, yeah.
All right. You just answered the question.
But not this switch.
Yeah, because it's.
There's two switching mechanisms here. There is a trigger strand in this coil, and then there's the switch on that over there. The paper clip.
This guy is a ghost hunter. It's probably the light. Oh man.
All talking about a portal and shit.
Open the portal.
Portal demons.
I wonder if you could hook up like radio next to this and hear voices and stuff. Here we go. We got this. Static noise. Static
amps.
radio.
0 amps.
We got 0. It's really small, but it's 0.
Shouldn't be moving like that with 0 amps.
What is going on? What is happening? Look at this. Look at how beautiful that is.
So we're at 50 volts.
That's
What are we looking on the switch? What's up with the switch?
Switch is arcing. Teeny arc.
Teeny arc, okay.
Let's see if we can get the teeny arc on the camera. No. Oh, it's every once in a while. You can see it.
Look at that. Wow.
That's the signature.
What does that say right there? How many volts? Peak to peak?
I can't see that.
Put the camera up to it so you can see it.
Sorry. $130, $160.
Okay. So 3 times on the oscilloscope. But as for output, we're getting about 31 AC.
Let me get it on there. The hertz again.
Oh, hertz. Yeah, we didn't do hertz. Frequency, this is the hertz right here.
There's the hertz. So 130, 150, 140, 150.
And this is the duty cycle.
Getting about 30.5 AC output. Yes.
And then, of course, we got negative DC output, which I don't understand. I don't get that. It isn't an AC configuration though, so that's probably why. Huh. What the hell just happened? There it is.
And the time machine is spelled Time space Masheen. Time machine. 88 miles per hour. I wonder how fast that's spinning.
Not that fast. So we need to get some pressure on the switch. So now we're doing 43, 44, 45.
That's bright. It's bright.
Look, 50.
We got 50 AC. And that's just from positioning the switch. Oops, I zoomed in.
See, and then you let up on the switch and all your light goes away.
Oh, we don't have a horsepower measurement.
Awesome.
We are building a pulse motor circuit. We have coils, a 3D printed rotor with 8 magnets in it. This maglev. Some circuitry with a paperclip switch. Power supply that's plugged into the wall. And we're doing lighting experimentation right now. Okay, then no, we don't have the horsepower rating. Can you measure RPMs?
Oh,
I saw it.
yeah.
Why is the tach meter always gone? Someone guess about 250.
250. You're way under ball there, dog. I'll let that run for a couple minutes. Maybe we bypass the switch. Do we want to bypass the switch and get a reading? Or do we want to leave the switch in there? We'll leave it in there and get a reading first.
You got to put this in a DeLorean.
618.
618 RPM.
Yeah, let's back these out like a 1/4 inch.
Is that a variac on the flow?
It is. need to move them back in.
Yes, yes, JT, the things that we do for love, man. Yes.
621. It's increasing now.
Welcome to the channel, everybody. Thank you for dropping in. Like and subscribe. Thank you for the 30 likes. We love you guys.
Awesome.
Thank you for the 500 rubies. Hook the rubies up. Memberships and donations are appreciated. We love you guys. Magnets and coils, baby. Yes.
That's a great sine wave, man. It's wicked. Wicked. Alright. So now let's bypass the switch and see what kind of readings we get.
So we were at 600 there.
620.
620 with the switch. With the switch is 620 RPM.
But granted, we had a very bright light. You got to think of all the things we did have.
Was it 618?
I'll see.
Okay. Oh, it's on there. He took a second reading. 621.5. So average those ones out. So 620, right around there.
Yeah. All right. Let's do this.
No hockey sticks. Sounds more like locomotive.
See how that reading is continuously increasing. Let's take a look at the...
Yeah, I got it. Oh, there's the wave. Let's see if I can get closer. Look at that. Put it in a shop vac.
Just for aesthetics, though. You know? Just for a sound, like a unique sound at your shop vac and nobody else's shop vac makes. You just throw this little switch here and... Just turn this crank.
Yeah, man, you'll be all right. It's a manual. It's a hand crank. Get it ready. And you're not even strong enough to do it once.
Just hit this button right here. That's all I gotta do.
And then you realize you have to get stronger.
So our light for our circuit is very bright.
Yep, you can see that. Yeah.
Okay, the frequency is a lot lower. A lot lower.
Yeah, man, we've been doing this for years.
And the duty cycle is a lot higher.
Yeah, check out the channel. Mike does in the house.
What's up, Mike?
Yeah, JT, check out the channel. Years of learning. There's some of that. There's some shocks. There's some smoke. There's some flying magnets. But yeah, there's a lot of learning too.
So I think that's all great and everything. The light's stable. That's cool. But I like the switch. So I'm gonna hook that back up. I'm gonna play with that.
Hmm. Interesting thought, Johnny. Wonder if he could use a controller from a flat car track to control the speed. Slot car.
If I took the essential pieces from whatever mechanism you're controlling and put it onto it's basically a timing issue. So you hook it to your timer. In this case, I don't think I could do it with a trigger coil. Maybe I could. Um, but I think you would hook it directly to your transistor and use it like a signal generator, kind of.
Hmm. Hmm. Interesting.
But no, I can't just conjure something up to resonate with something that's already created.
Thanks, Mike. We appreciate that. A real pulse motor enthusiast,
Yeah.
Papa Bale. And yeah, Alex, it's we spell it TIMEMASHEEN. Time machine. And more cowbell. Come on.
Now, who said this was going 250?
Who said that? That was Johnny.
Johnny, no. 790.
790, and that's no switch.
That's with the switch.
With the switch, what did you do? More juice?
Remember I moved it? It's tighter now. It's really tight. Look at how that is, man. That's tight. You're not getting any arc though. I think it's all going into the light.
He was just throwing a number out there.
Oh, my bad.
You're all right, but now in the sound is a good indicator with some of our motors.
883. 884.
Midas, that's perfect. TYMEMASHEEN.
God, you've seen it too, haven't you?
Yes.
God, we need to go ride that thing.
Yeah, go back.
And, yeah, go back.
So we can fix everything.
So we can see if the Triceratops really has a big pimple on its nose or not.
This is Quantum Leap, man. We have no affiliation with Quantum Leap.
All right, let's see if putting any voltage in it will help.
This is a pulse motor that's spinning really fast. What's the power supply specs?
600 watt DC buck converter.
Yes. I love that show, Mike.
904. 909.
Well, we're up. We got 9.
910. Woo.
It says 1120.
Oh. There it is.
All right. Then Al was the man. Always had that stogie. Bradley, this is a pulse motor. I think we got a PWM?
Yeah. Right over here. We got 2 of them. But this is timed way better than the PWM. I mean, I got a signal generator and a PWM, and I still think the trigger strain is way better.
Does the power supply have an adjustable setting on it for output?
Yeah, I've been playing with it all day.
We're looking at it. We're doing. We're having
The
fun.
amps are all the way up, and the voltage is almost all the way up too. And we got 0 amps being drawn, and we've got 64 volts going in.
That's a beast for what you're working with.
Drop it to 50 and play with the switch a little bit. Oh yeah.
So if we just say the words Black Friday, do you think you will get more money coming in? Papa Bale, Black Friday.
You in the title or something?
Yeah, no, that won't happen.
$9.40.
940. Checking some stat.
$9.45.
Blue plasma machine. Look out, Frankenstein. Yes, JT, yes. The things that we do for love, yes.
Well, we're getting the same amount of AC out. Actually, might get a little bit more out AC wise than we do putting DC in. And the maximum amount is 20 milliamps. So 0.02 on the amp meter.
Welcome to the channel, everybody. Thank you for dropping in. Like and subscribe. Drop
And
us a
that's when it
comment.
gets really bright.
Let us know if you have any questions. These are pulse motor.
I love that. That's awesome.
We're looking at pulse motor mayhem.
See that switch cuts everything up
Yeah.
nice and funky. Wow.
No, not that much. How many watts are going into the power supply?
How many watts are going into the power supply?
600?
600 can come out. I think 120 volts of AC is going in.
Oh yeah, from the wall.
At 60 hertz. So
Appreciate that, man. Yeah, there we go. You know it. It's a very balanced wheel.
I love it.
40 likes. Thank you guys so much.
Thank you, thank you.
And we got a bit of a maglev going on there, and 8 magnets in there.
50 volts going in.
What gauge in the coils?
All right, this is a 24 and 32 gauge bifilar. So, and then these two are 20 gauge. And it's literally, I'd say, about 6 pounds of copper.
6 pounds.
These are 1,500 turns a piece of 20, and this is 1,000 of 32 and 24, and that's adding up to be about 6 pounds.
How many miles is that? I'm just playing.
I don't know, you gotta unwind it and measure it.
Yeah.
One of those little wheel sticks. You gotta measure it out. Make sure it's nice and straight too. I mean,
That's right, because if it's kinked anywhere,
yeah,
you got to do the calculation.
you gotta do the calculation for the kink.
That's right.
There's a whole
And then
slew of numbers for this thing.
add it all into the plus, because that's all the kink plus or minus.
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 And then you gotta factor in, because each kink is a little bit more kinked than the regular wire, so you gotta factor in resistance that you just added to the wire.
Because of the kink.
Because of the kink, yes. And to make a kink, all you gotta do is get a pair of pliers and go, there's your kink.
We are not electrical engineers. It's like
Chemical bros.
we're not really chemical pros either, but yes.
Nah.
How many watts are you pulling from the wall?
.05.
Oh, you multiplied the two?
Yeah.
So half a watt, and then how many?
Anything underneath 10 milliamps, because there's no registration in the 10 spot. So let's say it's 5 milliamps. You do the math, and it's less than a watt, even at 50 volts.
So it's less than 0.001 amps.
0.00, less than 0.0.
0.00 amps. So, well, 0.005 because it rounds up, right?
It's less than 10 milliamps. Less than milliamps is 1,000. 1,000.
What is Ohm's law?
I don't know.
I'm asking them because they said it.
Oh. Yeah, I don't know what it has to do with what I'm doing or why it affects it in any way.
Because we are not engineers.
We're not scientists either.
We're not scientists. Welcome to the channel, everybody. Thank you for dropping in. Like and subscribe. This is Papa Bale. We go live every once in a while. He goes live more often.
I don't study. I haven't studied any of this stuff. I just dove in, and this is what we get. I said to the wind with all of it. I mean, I don't care. Ohm's law, the thermodynamics. I don't give a Weechee's heap about any of it, so you don't need to mention it. I mean,
Viva la resistance.
You can mention it. I don't really mind if you mention it. It's just that I don't have anything to say. So you're talking to the wall.
We are building pulse motor right here. There's a pulse motor. We got some coil. We got some rotor with
And
some
you know
magnet.
what? Just for you guys, I will study Ohm's law.
We got some circuitry with transistor. We got a power supply powering a light. What's up, Yanni?
800.
Yanni is in the house.
What's up, Yanni? Woohoo!
What's up, Viking Blood? We are working with pulse motors this evening. Oh, good. You did hear me. Good, good, good. Oh, what was that? 90% gator clips. There are a lot of gator clips, man, and there does need to be more teeth in these gator clips.
Yeah, man. 100% gator clips. No breadboard. Well, actually, there's this apparatus right here that the transistors in. And it gives you a little bit more connection room for the alligator clips that you're going to use to put this thing together. So you got to get one of these. Or you can learn how to solder.
All right, now, JT, does that mean we have to multiply something into something?
Huh?
We got electrical engineering stuff coming through here right now.
Awesome.
Yeah.
Awesome.
And I'm assuming this is a piece of a calculation that will enable us to talk about our numbers in a different way.
You would assume so. Yeah.
You would assume. Okay. Impudence. That word sounds awesome.
Sounds like the end of a banana.
We are powering this bright light in the back, this pulse motor in the front. Thank you for dropping in, like and subscribe.
This little transistor is really kicking ass.
It is. Look at this thing sticking out of there, looking like a thing.
It's taking a really big beating right now, 400 milliamps.
50 ohm impedance for impedance matching. Okay, so we'll definitely like.
So what's going on? Is that because of the light? Are you guys talking about the flicker of the light? What's going on? Why is that even important? I'll check it out, but I mean, I just want to know. What's the big deal?
Put some oil on that bearing.
No. God, man, people are all like, lube it up, man. Lube wrecks bearings, man. Lube destroys them.
Lube destroys more things than just
If
bearings.
you're gonna put any kind of lube on there, where in the hell would you go?
You got some graphene,
No, graphite, yeah.
graphite powders.
You use the graphite powder, that's it. You don't want to use wet lube. You don't want to use lithium grease. You don't want to use any of that crap, man.
That's
You
right.
don't.
Oh, do a LED versus incandescent bulb experiment.
Well, it is an AC hookup. Maybe we can. It's not. It's one of these bulbs. So I don't know. We'll
Oh, I
see.
think those are lower wattage demand. I don't know if we have any actual incandescents here.
Yeah, man. Those bulbs. They don't make those bulbs anymore. And if they do, they sell them like in the back aisle underneath 30,000 other bulbs that are LEDs. That's what they do.
Yeah, the fluorescent
They don't
LED.
give a crap what you want.
No, I know
don't care.
they phase them out for. It might even be against the law to buy them in some states. I don't know though. I have to look it up.
Now, since it is an AC connection, it might light up. It might light up. Let's see.
R.I.P. incandescent light bulb.
Lighting up! Oh! Yeah, I couldn't get that one to light up before.
Nice.
But that might be a cheap one too. I don't know. I think those are filaments or collagen or something.
Yeah, it's coming up slow. Yeah, it's about 10 watts. 11 watts. 12 watts. Okay, but it did start coming on around 8 watts.
But you gotta understand that the power that goes in from here, it doesn't need all of that to do that.
Any capacitors?
No.
Impressive.
Thank you. I put a capacitor across the switch and it started to spark.
Mm-hmm.
So that's not good.
Yeah,
Sparking
no.
is bad.
Sparking, popping caps are bad.
Yeah, well, not just the popping of the cap, but I mean the switch was sparking instead of arcing. But yeah, he's talking about the one time I discharged the cap, like right in front of my face, and I didn't know I was doing it, so it just kind of happened suddenly, and then I had to like feel my face, and I just made sure my head was still attached.
That was scary. Yeah.
Because it sparked up, and this capacitor was up right here, and the spark went up like to here.
Yeah, then I'm like, "Are you okay?" And then he he did the face thing. He's like, "I'm here, I'm here." He didn't really. He was dazed a little bit.
When it happens without notice, I mean, you're just like, what the just happened to me?
Thank you, Viking Blood. And we are in Michigan, Metro Detroit. Is there a difference between sparks and an arc?
Yes. An arc is plasmic. A spark is not. A spark is electricity. Plasma is not electricity.
This is plasma that we're looking at.
I know there's probably some people that are going to say, yes, it is. It's like the new age electricity. And I'm gonna say, no, it is a totally different phenomenon.
New Age. Next to the Casanova candles and the Caligula incense.
Arcing is cold, sparking is hot. That's another way to look at it.
Could you go ice fishing and heat your tent with this?
Yes. You need to hook up your ZVS though. Your ZVS driver. You need to hook that up. And you need to hook it up the way it's meant to be hooked up, and then you can heat your den or whatever it is.
Yeah, 12-volt battery.
You need two 12-volt batteries. You need a 24-volt power supply to run the electromag rotor. So cool.
Hey everybody, welcome in. Thank you for dropping by. Like and subscribe. Let us know if you have any questions.
I will be right back.
We've got some excellent training and fire mitigation skills. Check out the channel. You can see our experience there. Right, it's more like smoke.
All right. Sweet. What's the clock?
1 hour and 20.
20.
Thank you for the high five, Alien. Appreciate you.
Thank you.
And thank you for the rubies.
Thank you, thank you. Oh, there it goes. The light is lit. I don't know what kind of light bulb that is, but it is lit.
Let me see if I can get the arc. Yeah, there's the arc in.
And that's 50 volts. Now the arc gets bright blue when it's at 50. Come on, run away, run away. 951. Oh, it went down. 949. $951 is our max so far. We can't get 1,000 like this. I don't know why. Now there's this one coil that I use it all the time, and I can get 1,000 easy. It's like...
Welcome in, Jacob. Jacob wishes he could do science all day. And he says this is cool. I think he does do science all day, but it's more out of love than taking data and anything else. We don't really.
Yeah. I draw some pictures every once in a while, but I just try to, have fun. It's really simple. What it is, it goes here, it goes here, and it goes here, and it goes to here, and it goes back to there, and it goes to the transistor, and it goes back to the power supply. And bada boom, bada bing, you got something that does this.
The circuit, and it powers the bulb. Oh, a gauze meter.
Yeah, for the magnets.
See how much gauze the coils are producing.
Probably a lot, especially the big ones.
Yeah, well, measurements are the only way to progress. I don't know, man.
Who am I measuring for? Who am I measuring for?
Getting things to turn on. Like if our goal is to get the bulb to light, and we know the wattage of the bulb, then we just hit a threshold, right? Yeah, this is all about playing. All of this is playing.
Yeah, I'm having fun. And I've invited you to see what I'm doing. That's pretty much it. You can ask questions, I'll answer them if I can.
Yeah, we are not engineers.
I don't need to, there's no reason for anybody to be saying anything other than asking a question. Like, what is this? That's a good question. It's a pulse motor that can light a light bulb. It's a simple circuit. It is literally the simplest pulse motor circuit with a transistor that you can have, plus 2 coils. It's that simple. Now what's really cool is that when you put it up to 50 volts, which I normally never do, I'm running on 12 volt batteries for 2.5 years. I just broke 24 volts just recently, and now I'm up to 50, buck converter, you get there quickly. But yeah, the only thing different about any of this stuff that I've done is the paperclip switch and the trigger coil combined. Right now there's a lot of pressure on the switch, So the amps are a little high, 290 milliamps. But if I remove this coil from and remove the weight, see we're down to
Yeah, the definitely changed because now that's flickering a bit.
yeah. We're down to like 200. We can do better though. There we go.
Hey, Michael, one thing, you're blind. And another thing, peace.
Enough said.
You're right, I'm new at this.
Bring it.
I got him.
All right.
I'm not really new at this, I just forgot. I hid the comment instead of the user.
You hit the comments instead of the user?
Yeah, so he just came up and laughed at me. Yeah.
Oh, that's funny. That's good. Silence the lunaticals.
50 likes, thank y'all. Oh my goodness, what a showing.
Yeah, that is.
Crisco would destroy this thing, man.
No, man, you guys misinterpret what the noise actually is. Crisco isn't gonna fix that. Lithium grease isn't gonna fix it. Graphite isn't gonna fix it. There's a bearing, ball bearing missing. They took one out intentionally to increase the speed. So there's a lot more motion in there than normal bearings. These are not normal bearings. They're not going to sound like normal bearings. All right, let's move on.
All right. It's at an hour and a half now. So.
All right. Is that a little bit heavy?
No, but I'm getting ready. I'm getting tired.
Me too, man. I think we did really good.
Yeah. It's 11 o'clock. 11:09.
All right, let me cut this off.
Thank you guys for the show up and the show out. Thank you guys for the rubies and the gifts. Well, you, JT, but there's a lot more people here than you.
What happened?
And a lot of people that do come here don't know as much as any of us. And a lot of people that come here know way more than all of us. So it's like, it's a community that flexes on knowledge when it shouldn't be that way.
Seriously. He's right about that. I mean, oh my God. It's like I hear the same crap all the time. And it's like, I know.
Thanks for dropping in, Midas. Appreciate y'all. No, go ahead.
I was just gonna say, get bent, losers.
Yeah, if you're gonna, well, yeah, if you hold that,
should have had that one
flexing on the knowledge kind of thing. I agree with that. I do.
Yeah, man. I think that all of the old school stuff is way overplayed, and it doesn't need to be brought in the conversation at all. It doesn't. It's not important. I mean, it's like breathing air. It's like second nature. You don't need to. You look at this and you're like, free energy device. That's your fucking misconception, not mine.
Thanks, Johnny. Appreciate you. Have a great night.
Peace. All right, I'm done.
All right, thank you guys.
Thanks.
Like and subscribe.
Bye now.